Have you ever wondered how we get images of the Earth, or of the Moon, or of the Philippines from above? Come join me today at the ground receiving station of the DOST-ASTI to learn more about how we have eyes in the sky. I'm your host, Francesca Palabrica, and this is Sirkit Rikit. Hello everybody, I'm here today with Mr. Ellison Castro from the DOST-ASTI, who was in charge of the optical calibration for the Diwata 2. So, Mr. Castro, thank you so much for coming today.
Thank you very much.
Can you tell us a little bit about yourself?
I am Ellison Castro. I'm working here at the DOST-ASTI under the ULAT project, or the Understanding Lightning and Thunderstorm project of DOST. I was previously in charge of the Diwata 2 payload calibration at the time that it's still in the Earth. So, wala pa siya dun sa space. Currently, I am working on Filmora 8 satellite for detecting convective clouds for better weather forecasting.
You mentioned that you handled optical payloads.
Yes.
What does that mean exactly?
When we say optical payloads, these are technically a little bit more like cameras and is a passive sensor, as they say. It only takes light reflected by the Earth to the satellite. So it's different from a thermal or other kinds of sensors which releases a pulse from the satellite, and then that pulse is then reflected by Earth and then received by the satellite.
So would you say you're in a way in charge of the cameras of the satellite?
Not technically in charge, but I am one of the people which calibrated the optical payloads of Diwata 2.
So what's the difference between the camera on the Diwata 2 as opposed to like a regular mobile phone camera?
Pag sinabi kasi nating regular phone camera, it only sees RGB. So, ibig sabihin red, green, and blue channels yung nakikita natin. Pag kay Diwata 2 naman, in addition to the RGB, we can also see infrared light and kinds of radiation na invisible to the human eye.
What are the applications of these images? How do these images help the average Filipino?
I think the most prominent one, of course, is makikita natin yung image ng Earth. Somehow similar to Google Earth. Pero meron din tayong information in the infrared, which has a wavelength a little bit longer than red. Ginagamit natin itong infrared na ito para malaman natin kung healthy halimbawa yung mga tanim natin or yung mga farms. Pwede rin natin siyang gamitin kung aling mga parts ng Pilipinas yung nawawalan ng puno kasi bumababa yung infrared signal at that location. Pwede natin gamitin sa mga baha. Pwede natin makita aling lugar yung nabaha na. Bago tayo magpadala ng mga tao doon, at least alam na natin kung gaano kalawak yung baha na nakikita natin. Pwede din gamitin ito sa mga change detection. Ibig sabihin, titignan natin yung colored images. Ibig sabihin yung RGB nung nauna nating image halimbawa ng isang lugar. Tapos, i-compare natin dun sa mas recent na image. Mas malaman natin kung gaano sila nag-iba. So, pwede natin makita to kung tinatawag natin na urban sprawl, paano lumalaki yung isang lugar or yung isang syudad. Pwede natin makita din kung naayos ba natin yung mga daanan na kailangang maayos. Tipong mga ganong klase ng mga uses for Filipinos.
What is the most amazing picture you have seen? Meron bang larawan na napamangha po kayo?
I think yung image ng moon na nakuha with the Diwata 2 HPT. Although sa HPT naman ay mostly RGB siya, tapos meron siyang maliit na near-infrared. Pero yung image natin kasi ni moon ay RGB lang. Pero yung makikita mo yung mga craters ng moon na nandoon, and yung technological precision nila na i-point siya away from the Earth tapos ipo-point nila sa moon. So yun yung parang amazing siya na tignan.
Paano po kayo napadpad dito sa optical calibration?
Nung I think nagsisimula pa lang si Diwata 2 is naghanap sila ng scholar na ipapadala sa Japan to actually pursue yun nga si Diwata 2. Tapos I was offered this opportunity by Dr. Gay to go to Japan tapos mag-aral doon ng masters. At the same time, I would be doing the calibration ng Diwata 2 habang nandoon. Ibibigay sa amin yung mga optical payloads in Diwata 2. We calibrate it there or some other place, and then we send it back to the other team. I-assemble nila, and then ibibigay nila ulit sa amin to recheck, and then after nun, ibabalik namin yung optical payloads sa kanila to actually prepare for the launch.
What is the most rewarding part of your job po?
I think yung medyo nakaka-publish ka ng papers doon sa high-level journals. Halimbawa, I had the opportunity to actually have a journal published under Diwata, pero under Diwata 1 siya. You learn a lot of things. Hindi ko in-expect actually na matutuwa ako sa ganitong klase ng work kasi way before, I was interested naman din in space pero not on Earth. Pero yung medyo nalaman ko na may mga ganito palang kailangang alamin na ito dapat palang ginagawa, it aroused my curiosity to actually further the understanding kung ano ba nangyayari dun sa ganitong technology.
Ano naman po ang pinakamahirap na parte ng trabaho?
Kapag stuck ako sa ginagawa ko dun sa work, wala akong matanungan. Kasi bago pa lang naman yung space science dito sa bansa. So, wala akong masyadong matanungan. Bawa kung may ganitong equation na lalabas, anong kailangan kong gawin o paano ko siya parang ima-manifest doon sa technology na yun para magamit siya. I'm on the more theoretical side ng space science, so wala akong masyadong matanungan. Although nandun naman si na Doki halimbawa to actually help me to push me through the correct direction. Yun yung sigurong pinaka-challenging.
Do you have any last words po for any of our viewers who might want to be like you in the future?
I don't mean to discourage you or anything, pero if you are trying to pursue sciences, be sure na you are ready to actually yung magpuyat and all, tapos mag-isip. Dapat you are comfortable with doing maths, actually doing with people. Although nandun naman yung mga kasama nyo, people you are also trying to pursue science with. Tapos, hindi lang kasi kailangan na you have the passion for the sciences. Hindi lang kailangan na ganun. You also need to have the endurance, yung pasakit na dalan rin ng science.
Thank you so much, Mr. Ellison Castro, for your time today, and thank you for watching up to here. Once again, I'm your host, Francesca Palabrica.
And I'm Ellison Castro.
And this is Sirkit, Rikit.